Now we're moving into this idea of osmosis. So the definition is osmosis is the diffusion of water through a selectively permeable membrane. So again, the keys here is it's water. We're really looking at how does the water move and through that permeable, selectively permeable membrane. And again, thinking of the cell membrane, it's going to regulate what is coming in and out of the cell to some extent. And that's what that selectively permeable means. This allows water to move, but does not allow the solid particles. So when we're looking at osmosis, we're really looking at movement of water. Okay, so if you can kind of think of that, of osmosis in that respect, that's going to help you when we start looking at how does the water move. So our example down here, we have the selectively permeable membrane, and we have a kind of pure solution, has low sugar concentration but high water concentration, and this one has high sugar concentration and low water concentration. So we are going to look at how does that movement of water go. So we have high water content concentration. Remember, water is going to move from high to low. So the water is going to move. We have lots of pure water, and it's going to move to the low water concentration. So you're going to get these little guys kind of going in here. Okay, so really focus in on the water. And we're going to do some examples in class, because we're actually going to look at, okay, if you have a cell in a beaker, which I like to use a little bit better than this example that I have here, but looking at what is in and outside of the cell. So we look at the concentrations, which has higher concentrations. If this is our pure water in here, these little dots here, they're going to move into the cell. And we're going to do lots of examples in class going through the different kind of solutions that we have. And that'll be on the next slide. All right, so effects of osmosis on cells. One of the things that we first kind of have to take a look at is the types of solutions that we're dealing with. Okay, so we have three that we're going to focus on: hypertonic, isotonic, and hypertonic. So if we look at the description, hypotonic is a solution that has less solutes than another solution. Okay, so when we look at the cell, water is going to enter the cell, and the cell is going to expand. Okay, so we look at drawing our little beaker down here. Okay, so a solution has less solutes than another solution. That's what you always want to compare. And I like to look at it as what's going on the outside compared to the inside. Okay, so if a solution has less solutes, so we're going to draw little kind of squigglies here. Okay. Looking at the outside of the cell, this has less solutes than the solution compared to the inside. There's a higher kind of concentration of water. So if we think of the movement of the water is going to move from a high concentration to low. And remember, these right here are the outside. It's not what's going on inside the cell, it's what's going on in the outside, kind of in our little beaker. So remember, in osmosis and diffusion, things are going to move from high to low. So we have a high concentration, per se, of water, so that's going to try and move into the cell. So if we notice our effect on the cell, water is going to enter it, and the cell is going to expand and might actually burst. what happens with a plant cell, water is going to enter the cell and it's going to become very turgid. And this has to deal with the fact that we have a cell wall and a cell membrane. So remember, the cell wall is going to provide some structure, but the vacuole on the inside of a plant cell is going to fill up with that water. Again, vacuoles kind of help with this equilibrium and storage and that type of thing. And so as water is coming in, it's going to go into this vacuole and it's going to kind of push on the cell membrane, which is going to in turn push on the cell wall. So it's going to be kind of very stiff. On the other side of this, we have the hypertonic. So if we draw our little thing here, and again, this is where we have a solution has more solutes. So there's going to be a lot on the outside and just a couple on the inside. So on the comparison on the outside, less solutes. Oops, excuse me. That should be more. We'll erase that. There's going to be more solutes. And that means lower water concentration. And when we think about that, wow, okay, concentration. So remember, focus on the water. The lower water concentration on the outside. So the water, it must mean on the inside is higher, so it's going to move outside of the cell. And that's why you get the cell is going to shrink, crenation. It's going to kind of close up with that. Water is going to be leaving. So that's what happens in the animal cell. So again, because of the plant cell, we are not going to have as drastic of kind of a change in appearance that we would in the animal cell. The cell is going to be, water's going to move out. This vacuole is going to kind of shrink, and along with it, the cell, kind of the membrane, remember it's fluid, it's going to kind of move as well. But you still have the cell wall, which is going to provide some of that structure for there. But it's going to become very flaccid in the sense that it's not going to be that kind of, when we think about celery, like very crisp, it's going to be more of almost like a rubbery, it's not going to have that kind of all that strength behind that. Then we have the middle road, which is the isotonic, and this just has to do with the concentrations are going to be the same. And because that, even though you're still going to have movement, it's going to not be this drastic movement in or out of the cell that's going to cause some changes with that.